Hi, everyone, and welcome to this month's Gen3 Community Forum. Um, I'm Michael Fitzsimons, and I'm excited to share the topic today, which is the Gen3 AI Commons Roadmap. We'll hear from Bob Grossman, the CTDS Center Director, on the vision and plans for this exciting suite of services and capabilities. Just one announcement, I guess, before we get started. This will be our last forum for the year. Um, at the beginning of the year, we have, I guess, traditionally now done an overall Gen 3 roadmap. We'll still plan on doing that. We haven't settled on the date for that yet. Soon that will come out, probably in the second half of January. Um, yeah, so I think that's it. And without further ado, I'll pass it on to Bob.
Well, welcome. The Gen 3 Community Forum is really an important source of, it's an important, a very, very important forcing function for Gen 3. And with the are launching a sort of a program to build out AI commons and AI meshes. Have been looking forward to trying to get feedback on the roadmap. So a few comments. This is a little different than the standard types of things when we add functionality to Gen 3. Um, a, a couple things, clearly AI is advancing so rapidly that it's hard to keep up. There are a lot of activities by a lot of different groups which are relevant. So what I'm going to talk about today is not the broader context of how AI um, is impacting biology, medicine, and healthcare and related fields. What I'd like to talk about is very specifically and very narrowly um, how we can bring some of these AI services into Gen 3, and how can we do this in such a way that they're likely to last a long time. I think what we saw with the GDC and Gen 3 is the core architecture had staying power. And I think that's how we're trying to think of what to do with the AI commons. So the there's been a lot of activity by our research group, and I think we've put 5 or 6 papers into archive. They'll be referenced here. We'll give you a website where they are. And we have 3 or 4 more coming out. And then, as I mentioned, there's a lot of activity very broadly in this space. So with that, I want to remind you one more time. I'll pause after about 40, 45 minutes, and then we'll go have some time for questions and have some times to hear what others are doing. But again, we're really narrowly focused on how to put AI support into Gen 3. So so the first some of you have heard me talk about this. A few of these slides are being reused. I think I'm interested in 2 questions. One question is, what API services and capabilities should we add to a Gen 3 Commons to support AI? There's a big long list from RAG to Flare to MCP to chat. Um, and both for commons, which give us AI commons, and meshes, which give us AI meshes. Um, Again, many of you, well, some of you have seen this slide before. This is the architecture of the GDC at a very high level. Um, it begins with to support the petabytes of genomic data. We use cloud-based data, storage objects in cloud storage long before it was popular and graph structured data. We clean, curate, and harmonize data. Then we make it available in Elasticsearch. And importantly, we put this all through FAIR APIs and created an ecosystem around the FAIR APIs long before anyone on the street or your cocktail party you go to talked about FAIR APIs. So this is the core architecture, storage, compute, Elasticsearch, and APIs. And so I think what became clear, and I will talk about one of the papers that sort of strongly influenced us, one research project that strongly influenced us, that I don't think there's a major change required. So we're going to add vector stores to the cloud and graph structure. We also have index support and semi-structured data. But for simplicity, I'm not talking about the semi-structured data. I'm talking in Gen3, I'm talking about. And we'll add different embeddings. We need to integrate GPU on-prem and in the cloud. We need to do federated. But we're suggesting very modest changes. Adding a new storage type and a few more APIs. I don't think we need a lot more. I'm going to try to explain things in this picture. On the right, and I'll do this from a Gen 3 perspective where we have a microservice-based architecture. We use the end-to-end design principle where we try to have as few core services as possible that last a decade or more, and then build new ways to get data in, new ways to visualize the data, but the core architecture stays the same. So, we have, I'll summarize those on the right. We do need for meshes to do distributed and federated APIs for AI. I'll come back to that. I'll break this into just a few things. One, we want multiple multimodal embeddings. I mean, you can think of one of the lessons of the GDC, I'll call out Martin and others who sort of understood the importance of this. Martin Ferguson is that, clearly if you're doing variant calling, there's no one best variant calling algorithm. And so we supported multiple variant calling algorithms. We made them all available, and we let people do analysis with them in this very broad ecosystem. And so I think that's an underappreciated lesson in the GDC. And so we're taking the same lesson here. I will give you some examples of why what we call an embedding-centric architecture is important. We're not going to select one set of embeddings, but we'll support multiple embeddings. And this is embeddings of all the different data modalities in Gen 3. I have a paper coming out where we talk what we mean by small and mid-scale models, but these are models you can think of that can be built just with pure CPUs, that can be built with 4 to a dozen or so GPUs. But we're talking about spending, standard infrastructure or a couple $100,000, but maybe a couple $1 million, but no more to build these small models. But we're going to talk about low resource models that could be built just with CPUs if we have the right embeddings, and that can be built with 4 to 8 GPUs, 2, 4, 8 GPUs. We need to store the models we built, so we'll need a model repository. We're really focusing on multimodal embeddings, which are computed once and for all and used in multiple small to mid-scale models within the commons, so the data doesn't have to leave in the commons. We are looking at how, the leveraging high quality curated data. We could build models in two ways: in secure workspaces with PyTorch or through container-based workflow execution services, both of which are available in Gen3 today. So at a high level, this is the architecture. If you dive down a little more, um, I've, oops, I've put uh, I've put a number of archive papers in here that go into each of these. I'll go over just one of them, the TCDA survival. Um, we have different agentic interfaces. There should be agentic interfaces. And these are today available in MCP. And the way we're breaking this up is we have AI models, AI tools, AI commons, and foundations. And I think our point of view has been influenced by all these and models that we're doing. So this is a similar view, a related view. You can think in this, our architecture we're thinking of as embedding centric. So we have multimodal data for TCGA. We have genomic data. We have clinical data, histology data, and clinical reports. We're going to support multimodal embeddings as a first-class object with vector stores. Users can define their own multimodal embeddings through secure workspaces, which we have, say, running PyTorch, or through workflow execution services, which we have. Call out. These are accessible today through Jupyter Notebooks, but we're integrating Funnel, which I'm hoping will be done by the end of November. We're doing that joint with OHSU and Carl Elrod so that we have a test compliant service to run these workflows, and these workflows then can be used to build models at a larger scale. And so we're doing inference. A particular model only needs to inference with the multimodal embeddings. So that's local, that's very efficient. And then you could build small to mid-scale models on the right, that either in workflow execution services or workspaces. Again, we're taking the point of view, not that you can't build more complex commons, not that you can't integrate a lot more in there, but that we want the sort of simplest architecture that might survive. So, this is just another way of looking at it. And I should say, we did put into archive, a lot of philosophy and point of, is that, if you can't spend $1 billion or $10 billion, you can't play, and you should just buy models from the big guys. At some level, the Hoffman and the Kaplan and the Kaplan from Anthropic scaling laws, and the Hoffman chinchilla from Google DeepMind just explain that as I build bigger models, which, from millions to billions to tens to billions of parameters to 100 billion parameters, loss goes down. But to build those, you need bigger GPUs, more energy, more CapEx investment. Recently, Yushin Chen, Anirudh Subramanian, and myself published a paper in archive, where we introduced what you might call a quality aware scaling law, which basically says you could build much smaller models with the same loss, if the data is higher quality. And so, unlike the data on the web, which can be very low quality and is getting lower quality, if you build a Gen3 Commons, you clean curate the data, and the data is very high quality, and it's extremely reasonable and sensible to think that you could build small to mid-scale models that outperform the largest models. And we have a number of papers showing that. So I want to look at this paper um, uh, that was just accepted into the Machine Learning for Health ML4H conference coming up in less than a month. Just to give you some idea of why think embedding centric, why think small to mid-scale models. First of all, the knobs in Gen 3 we have introduced and will be introducing allow any organization to keep the data within the organization, build small to mid-scale models that should perform as well as the larger models built with lower quality data elsewhere. And give the organization building the models complete control of what's shared. Do they share the data or not? Do they share the models weights or not? Do they share the software that builds the models or not? They have complete control of the entire pipeline. Do they participate in federated distributed AI? That's what we're building these AI meshes to support. So this is from the paper reference. Here, we're just going to build a small classical machine learning model, but we're going to use a number of different embeddings for the clinical expression slides and reports. This is a very thorough analysis as part of Stephen Song's PhD, MD PhD, or I guess his PhD thesis, where we're looking at this classical problem initially of survival prediction just because it's still so well studied. And we're going to do principal components and build this machine learning model. So again, this is a table from the paper where there are a large number of foundation and LLM type models built over TCGA data. We just really want to understand those. You can think of one of them, for example, gets about 7.7 predictive ability as measured by the concordance index. Just keep 0.77 in mind. And here we're going to just take this again. You can pre-train these models on we do this on a four node GPU cluster, or you can get these models from and just run them in an inferencing service. But here, if we do the embeddings and then do principal components reduction, you could see that we get roughly the same performance, not quite 10, 20% difference, or a 10% difference compared to just single modality expression. Notice that I think this is not well understood, but if these fancy models, which might get 0.771, if I just use demographics, age, gender, et cetera, and cancer type, at least with TCG, I get very good performance. So we're really interested in the incremental performance, and that's really important to keep in mind. And so if I take combinations of the different embeddings, I can get I can get modestly performing better models. But these are all very, very simple models, and they perform as well as some of the largest other models. So, and then, this paper also looks at how this varies by cancer type. So this is motivation. We have other papers that are in archive now. One paper creates 6,000 queries to the GDC and proposes an algorithm called QAG for query augmented generation. To save time, I'm not going to go over that, but it's I think as important as RAG, where we ask the question with an agentic interface, how do you take a prompt to a large language model about something in the GDC? With a BERT model, we understand the intention. This is from Artie Venkat and other researchers at the center. We understand the intent. We extract the entities with other models. We create API calls to the GDC. We pull back that information. We glue it all together. So that's QUAG. We evaluate that on 6,000 GDC queries that we validate to give what the right answers are. QUAG gets the right answer for all 6,000. The interesting, the paper, the references are at the end, is, the standard big models get 20, 30, 40% right. So, these specialized techniques that you can put into the commons, like QUAG, I think because we understand people who built the commons understand the data, understand the APIs. This is really something that can change, what you do with the data if you're an organization. So what's the short list? So that was motivation. So I want to have a discussion in a few minutes, but this is all we're proposing. For the commons, we're going to continue to have fair data services. We'll add that to the embedding. Michael Lukowski and others in Gen3 have a Gen3 embedding service that should be ready by Tuesday. We have sort of ad hoc VLLM-based inferencing services, but we will build a Gen3 inferencing service with VLLM and storing things in safe tensor, the format introduced by Hugging Face. I've mentioned the training services. We'll integrate the training and inference services with a S3-based model repository service that's will all be coming out in the first quarter. We've done a lot of experiments, as I mentioned, from QUAG and something called the Cohort Copilot for the GDC, of how we could put agentic and MCP interfaces. We have not done enough experiments, and we haven't even started the really important experiments for distributed and federated AI in a Gen3 mesh. So I'm not going to talk about this. But initially, the discussion I want to have is, if we just stick to these services, I'll have a few more slides. The first 6, are we missing anything? Will people be sad? We don't want anyone to be sad. That's part of the Gen3 community. So this is sort of where we are. This quarter, we have a beta of the first beta of the embedding service. We have some inferencing. We certainly have the embeddings. We have multiple examples, and we really couldn't move ahead with this proposal until we've gone through the examples. We'll be doing betas in the first quarter, and then moving to production between the first and second quarter for each of those 6 services. The AI meshes, we're going to start the examples as we roll out the AI Commons. And then I'm hoping we'll know enough for the beta. We're initially going to use NVIDIA Flare on top to create the meshes. We have mesh services following 10 pillars. So in a little more detail, the fair will simply add, we'll have an embedding, we have an embedding service. We'll add vector embeddings to the graph. So that basically will be ready in November. Um, and we'll just bring out more and more standard embeddings, find out what embeddings people want us to include, et cetera. The inference services, we inference in all the notebooks. We'll do a beta of a VLLM-based inference service, I guess in December and January. That's straightforward. Model training, we just have to wait for the Nextflow funnel integration to be done. So we have a service right now, it can be done through a notebook, so you could train in notebooks and use Nextflow. Um, um, so we'll create standard places for scattering, gathering models. The models can be in you can submit a model which will go in the repository service, then you could do local training. So that will be in the second quarter. The repository service will be in beta in the first quarter. There are lots and lots of agentic kind of interfaces. We'll start with Quag. We'll sort of create things so that the community could do their own things. We'll have a cohort co-pilot, and that's about it. I'm not going to talk about meshes and federated distributed. We have to decide if when we release this, is it 3.3? We have our research group. Um, we call it meshes amid scale models. Uh, this is the website, M3 Initiative U Chicago EDU. You can see the models we have, the tools, the commons, the publications, and events. So I think, it turns out about a decade ago, we called a data commons is a cloud-based data platform with a governance structure for managing, analyzing, and sharing data with the research community. We created the core architecture. A decade later, I think after a year of work and doing these, 5 to 6 papers and studies, I think I sort of am comfortable thinking of an AI Commons as a cloud-based data platform with a governance structure for managing, analyzing, and sharing data with a research community, that supports multimodal AI embeddings. This is an AI Commons, AI inferencing, AI training, and natural language and genetic interactions. So I'm not going over all the various things we've done. The real point is, I think you could do this with the narrow middle architecture. I think you could do this with a small number of services. I think, I spent part of my career doing inference engines. So I think we could do a fairly, just use VLLM as a starting point for an inference engine, use Hugging Face as the model. So we'll use Safe Tensor. And then, really use inferencing, which is so much less expensive than training, and let that be a core part of the Gen3 architecture. So I want to pause now for discussion and for questions and discussion. Then, and maybe in about 15 minutes, we'll go around for, I'd like to go around and see what other people are doing and see, how we can integrate that in here and see, if what you're doing is sort of providing an insight that we're missing here. There's going to be lots of models, lots of MCP, lots of interoperability. I'm not really interested in that very much because there's just so much you don't even know where to begin. I'm interested in this meeting of what is the smallest changes we can make to Gen 3 to support a decade's worth of AI research and operation. So that's the very, very specific thing I'm interested in. So over to discussions. Maybe you could raise your hand and Michael or someone can call on you. The first Wednesday in November is a good day to ask questions about AI Commons, so I encourage you to step up. I did it very quickly because I've been thinking about this for a year. Uh, so I may have done this too quickly without enough introduction. Martin, will you yes, you could bring your own data. Yeah. There's we will support Laura. Uh, yeah, so you could bring your own data today into Gen3 Commons, and Laura are one of the things we support.
I'm sure
To,
you
to,
all have thoughts about
to,
AI, so
to
might
be
have some ideas.
to be clear, Bob, I was asking if you'd let me use your CPUs to do it.
Ah, you mean our GPUs?
Yeah,
Oh, you're asking about the pay. I am silent on
I'm
the
always asking about money.
uh we so we've put a lot of effort into Gen 3 recently, over the last couple years. So we have user pay models. So if a Gen 3 wants to operate on what we think of um, as what you think of as blanket billing, then obviously that blanket biller can cover GPU costs. Um, we are going, I have to do a demonstration of an AI Commons next Tuesday in New York City, and then all the following week at SC 25 in St. Louis. Um, my understanding, Jawad, am I correct? We'll be able to use on-prem GPUs will be enabled by supercomputing. Is that correct?
That is correct, Bob.
Thank
We
you,
have,
Jawad. Thank you, team. Were you going to say something, Jawad?
yeah, we'll have some GPU-based applications that will be served in sort of a hybrid mode where the GPUs are on-prem and the application is running there, but you just see it as embedded into your comments, which is pretty cool.
So I think that's absolutely essential. So I should have brought that up. Um, the cloud-based GPUs are so expensive that I think hybrid mode has to be the way that Gen 3 has to support hybrid mode. And so I'm very, very pleased that Jawad's team um, has enabled that. So, obviously this depends part on your governance structure, but um, the way we run CTDS, the security review has approved this, and we can operationalize this. I spent the morning at OCC and looked at their CSOC. Their CSOC, in collaboration with Crumware, is maturing. And I'd like to see the CSOCs give automatic support to hybrid computing, where you can support AI-based models and applications with on-prem GPUs as well as cloud-based. So I just think that's the only way to make this practical. So that was a long answer to Martin that there is no economic model here. We have to obviously rethink, and I should call Martin. I should brief you on how we're rethinking sustainability for our projects. We are simply thinking that more and more costs of certain things that are expensive on the user side will be cost of computation, if expensive, will be passed to the user. You can do a lot at low cost. So one of the reasons we're interested in this embedding centric architecture, if I can use PyTorch and if I can use um, um, classical machine learning, well, it's not, I guess it's class. Well, use standard machine learning and build small models in PyTorch on CPUs that don't cost very much, that do almost as well or better That's why I went through that example. That example was done all the computations of the models, not the inference, were all done on CPU. So um, I just think this is a very important part from a cost point of view. Bernie is asking, how will data governance? Bernie, I don't understand the data governance. Nothing changes here with data governance. Can you ask your question?
Yep, sure. Sorry, Bob, I don't have
Yeah.
my video on. I'm just traveling. The so I'm interested to know, we have the situation on some of our commons where a user can be granted access to a subset of the data due to data governance reasons. But if you have an AI model trained on your entire data commons, that potentially, if they've got access to using that model, they've potentially got access to more than the data they're approved to use. So I'm just curious to know.
Well, they can, that's the right question, Bernie.
Yeah,
That's the right question. So first of all, the front end for the cohort discovery is done. There is work for us to do in the back end, unfortunately. So that's not all done for cohort discovery. So I guess what I meant by nothing changes is we're going to have to, if if a if an so first of all, um, the embedding models have security and governance of their own. But once the embedding models are there, and they can be built with data that's outside the commons, that's one of the really important things. So if you think of an embedding centric approach, then its advantage is you could build the data on data that the user has access to. So it could be these third-party inferencing because we're just inferencing expression, et cetera. So that's an advantage of embedding centric. Then say the user has access to a particular cohort through cohort discovery, they improve through REMS. They then can build a small to mid-scale model over that data that they have. That's the advantage of an embedding centric approach. Obviously, then that model can be put into the model repository. Then the question becomes, can another user who doesn't have access to that data access the data from the model repository? I think that would be naturally dealt with in a standard way. Be just it's a standard access controls. Either the user has access to that data or not. If he doesn't, he or she can't touch the model. So I think an advantage of our architecture is it's relatively straightforward to put the governance and cohort subsetting in exactly what you described. That's why we have a repository service. That's why the inferencing can be done with all sorts of inferencing. So, for example, clearly, if there was a specialized inferencing algorithm that was computed over all the data for which that researcher did not have access to, then that user would not be able to use that inferencing algorithm, that inferencing model, that model for inferencing to do their research because they didn't have access to the data that produced the inferencing. But it doesn't have to be that way. You could certainly, make these generic, well, not make standard inferencing algorithms for which the user has access as one of the choices. So um, I hadn't thought a lot about your question before this, but I think our architecture, the proposed Gen 3 architecture, very, very naturally satisfies all the requirements you would have. Bernie, did I miss anything in the explanation?
that makes sense, Bob. Thanks for your answer. I think the generic sort of topic that will get asked a bit is, if we add AI to our data commons, are we going to accidentally leak data or information that users, because the custodians are not comfortable with users accessing this data until they're approved and so on, and they may not get approved for everything. So I guess the generic theme is not leaking information through an AI model in some way that we hadn't anticipated, and reassuring people that that's not going to happen, I suppose, is the theme I'm thinking about.
Yeah, and I would say the model repository, and we have to put this in your requirements, so you may want to help write that requirement, but the model repository, each model in the model repository has to have accurate information on who's allowed to use it.
Yep.
And if we do it that way, we're fine. If a user can't use a model in the repository unless he or she has access to that model. By definition, if the user is in a commons, they have access to that data, and then they can build a model over that data. But that model has to remain in the repository unless it's an open access model. And that's another reason that the model repository is a core service. And then the role of the federated and distributed, well, just think federated here, is what are the rules when that model could be used by another commons by another user? That's that's why we have the mesh and the trust relation in the mesh. And that is what we're working on in the next quarter. So I think it's exactly the right question. I think by having different types of inferences, if we just had one inference, we wouldn't have this flexibility, but you could have as many, I'm sorry, if we just had one embedding, we wouldn't have this flexibility, but we could have as many embeddings as you want, including embeddings, say, for expression that were built on data that's widely available and hence can be used by anyone in the commons. If someone wants to build an expression model in AC/DC or cardiovascular that's just on sensitive cardiovascular data, that embedding service could be added, but it would be restricted who could use it. They would have to have
Yep.
access to that data. So I'm comfortable. Keep thinking, but I think we just have to put the right requirements into the repository and inferencing service.
Yep. Thanks, Bob.
How can we not have more questions? All right. I've waited for questions. Let's do round robin. What interesting AI work have people done that might influence what additional capability we put into a Gen 3 AI Commons?
Do you want to call on particular groups, Bob? Is that what you're?
I'm afraid I want people to volunteer.
Well, I can start maybe if nobody else wants to talk. So one of the things that we're working on right now, and this is within the, I guess, context of GA4GH, is that the cloud GA4GH cloud work stream is starting to kind of look at what are the different APIs that are necessary to enable federated machine learning. And I'm curious what you guys are thinking about in that realm, and if that's something that you guys would be interested in participating in.
Yeah, I mean, that's exactly what we have to think about. I mean, we've thought a lot about it. I think until we do the same kind of, we spent a year and wrote 6 papers or 5 papers doing really detailed experiments. I think, we'll obviously participate in that, Kyle, but until we do the experiments, there's natural stuff to do, which I haven't been on those calls, but you gather models, that's easy. We've been thinking about that. We are starting to do we'll be starting to do some experiments, but I don't have anything to add until we get deeper into it. Are they, there's two granularities. The first granularity is when you do federated by you just scatter a model and return the results. That's how everything works fairly simply that way. We'll be able to do that in January. The much more complicated is when they do distributed training with Flare or something where you have to coordinate a common data, you have to coordinate this more fine-grained thing. What's the Cloud Stream thinking of?
Well, I think right now we're just exploring the problem space and trying to understand everything that's going on. I think the issue is that you mentioned NV Flare, but there's like six other competitors to it.
I know
Um,
we had to choose something,
and
and
so
so
that's where
yeah.
and so that's not so we're ending up with federations of nations. With like people picking specific technologies, but if you
Yeah.
don't pick that technology, you can't be part of that federation. So that doesn't actually feel like a federation per se. Um,
Well, the way we're thinking of that is each mesh can make their choice for their each. The reason we're having you can join multiple meshes and we could put multiple federated and distributed APIs. We're starting with Flare. There are lots of them. There are lots of companies. It's a mess.
mhm.
The way we're thinking of the mesh is the mesh is the unit in which you decide what API you want and who you talk to.
And then on top of that, I think there's something that was kind of indicated earlier, which was like the cost model. Martin mentioned, and one of the things in there is delegation of secrets and credentials. And it's one of those details you don't want to worry about, but you have to, like, at some point, if you're going to do operations on somebody's behalf, you need to have their billing account. How does that get delegated out into the Federation?
So that's partly of why we're introducing this AI mesh. So you're part of the 10 pillar stuff. Um, and the other thing we're doing, I guess mainly for AWS Commons, you'll see in the third-party providers like OCC, where there's going to be a lot more ability to monitor closely and share cost information. So we're pushing that all to the mesh. So we're happy to talk. I mean, I see a bunch of companies. We had to choose something, so we chose Flare. What are the top three or four you see after Flare?
Um, I think there was we've talked to was it the people behind APPFL,
Hmm.
and then I think there was a flower, and then I'm blanking on some of the other ones.
Yeah, there's a bunch. There's one
Yeah,
at
there's a tensor or the federated tensor flow, or, but a lot of them they are primarily considering the algorithmic side of it. They do not have much around the what we'd call the enterprise infrastructure side. So like even in vFlare, how do you do account management? How is that,
That's
so
why
that
we're doing the mesh. We're putting that
exactly. And
all
so I think
into the
that
mesh.
might be where the opportunity is better definition around the infrastructure protocols, but we don't like I think the AI companies will probably do better job at the actual AI level APIs, but I don't think that like the data discovery, data formatting, uh, data governance, cost control, and stuff they don't put as much effort into
I mean,
because they're like assume that you'll be inside their ecosystem and it'll be very monolithic from their perspective.
yeah, Kyle, the other thing we can think of, you're part of this discussion is we are, we have a paper coming out, hopefully before supercomputing, where we talk about node and mesh cards and how do you put information into a node card so it could join a mesh automatically. We have not asked the question. It's a natural question. I don't know who's on our call, but you would ask the question, if I want to bring up a mesh that supports federated AI, what additional information do I have to put there to answer all the questions you just brought up? That's part of what we put in the mesh, but we haven't thought of that carefully yet.
Yeah, and I think one of the issues there is like how much of this is going to be, you put together a card, how much of this is merely metadata for a human to use for configuration, and how much of it is something that can actually be machine parsable and automatically, but the problem is if you go for that direction, then I mean, even like what kind of GPUs do you have is a fairly complex question. Um, and that we don't have a
So,
good like ontology
yeah,
or syntax for it. We're just like, well, they're this model of NVIDIA, and then you can infer the amount of RAM and if it could theoretically run your model.
I mean, I think the way so first of all, that's why we're supporting on-prem and public cloud. I'm thinking of these meshes as research groups who want to work together, talk a lot, and want to quickly bring up a mesh to do a joint computation. And so I don't see this as initially in the first year or two, as a couple years, as you just look for meshes and do random stuff. These are people who want to work together, and we're trying to give them tools with Gen 3 meshes to make it really easy. But they're not strangers. And so some of these things are going to be a little easier. And, we can automate, this is what the paper says, everything except the handshaking you need to do for OIDC Connect. Other things can be automated. We'll have to see if that carries through for these things. But if we're taking a model out of a model repository, sending it to the other commons in the mesh, writing to something and then bringing it back, that's something that could be automated. Since I'm not trying to, there may or may not be enough GPU, but if the GPU fails on-prem, or if it takes longer, say there's not enough GPU and it takes a day, we don't see this as, we still see the human being in the loop as we do this in the same way humans in the loop when you run a model. And when you run a GPU model now. So that didn't answer your question, but we'll certainly enjoy talking in that group. I got to leave in a few minutes. That was I mean, Bernie, Martin, um, Kyle, those are great questions. What else are people doing um, in groups other than GA4, GH CloudStream that bear upon this?
I guess if folks don't ask
Uh,
now, they're free
Wait a
to.
minute, Alex, your hand's up. It looks like Alex got.
yeah. Hi, Bob. How's it going?
Hi.
I joined a bit late, admittedly, had a conflict. Apologies, but looks like this is being recorded, so I'll enjoy revisiting this with Michael at some point, hopefully. Quick question. Given that I don't know all the context here, I really like the idea of where you're going with your previous answer to the question I think that Bernie asked, or maybe it was the one after that about, performing like joint kind of like analyses on data sets across a mesh. Would this be a forum where I could ask, like, here at the MMREF, where we are working with multiple myeloma patient data, genomic data, whole genome, exome, RNA-seq, spatial, single cell, if we wanted to kind of look to doing these kinds of like cross-platform type analyses in this way, to learn about what kind of data sets are actually out there in other Gen 3 data commons. And presumably the mesh is just native to like the Gen 3 user group. Am I right?
Well, it's a little more complicated than that. We've built 4 production meshes. The 2 of them, the HEAL mesh for pain management, is a big NIH program where the data is in, I forget, 10, 15, 20 repositories, only one of which is Gen 3. So the way
Mm,
the mesh technology is designed is if you have APIs, we'll build a mesh around that. Most of them did not have good APIs, so we had to give
mm,
them a crutch where we built a mini Gen 3 Commons that interoperated with theirs because they
mm,
didn't have an API. But
mm,
the idea of a mesh is it doesn't have to be Gen 3, but as in the 10 pillars paper, it has to expose a certain amount of APIs. So the question you can
Mm,
ask, so those are pretty easy. They're fair APIs. So the way I started this was, what are the smallest number of additional APIs that a commons or repository, whether Gen 3 or not, could expose to be an AI commons. Once they do that, we could create an AI mesh.
I see. I see.
So it's not so much designed to
Limit. Yeah.
find arbitrary data out there. That's another problem. It's designed if there are 5 or 6 or 10 or more platforms with data, say cancer data, that expose APIs, can they interoperate? And that's the question we've been looking at, which should be relevant to you. Then the related question is, well, I mean, that's the question we're interested in. So from your point of view, you just by using Gen 3 will get these AI services. On the other hand, you have to configure them. You could decide to always keep the data in, always keep the models in, but to participate in selected federated operations,
Mm,
partners you approve of,
mm,
and with the cost sharing you approve of.
mm. Okay.
That's what we're designed to do in the first year.
Sounds good.
Does that
Thanks.
make sense? I mean,
Yeah.
if so, look at it this way. If it doesn't work for you, you better speak up now because we're really want this to work. It should be your use case with other people who have data relevant to multiple myeloma.
Um,
And if it's
Sounds
not,
good.
this is the form to say you want to put stuff in.
Yeah, right. Okay. Well, I'll put up my hand. Yes, I'm interested and would like to do that. So speak on behalf of the foundation. Let's get this
Yeah.
ball rolling.
Yeah, and we're just trying to give you the ability. The timeline is AI Commons will be coming out first and second quarter. Mesh discussions are starting in first quarter. Jeff?
Uh, I'm actually Ben Gowdy. I don't know. I have no idea how
Oh,
I'm logged in as Jeff. How are you, Bob?
I'm
Um,
fine.
sorry,
Aside,
I came a little bit late, so I've also missed a little bit of the context. But you know, is the right way then to think about this AI mesh, not in the same sort of a, I guess in some of our previous discussions around this, I'd thought about this in a similar vein to a sort of trusted research environment, almost sort of setting where we're being sort of very careful with what we're saying about sharing the data. But actually here it's a little bit different. We're saying, well, we're sharing either models or the
if you
embedding.
want, I would say it this way.
Mm,
The AI mesh gives you as an operator for Gen 3 Commons knobs. Those knobs can make a secure research environment that has very limited interoperability. Those knobs can be opened up a bit within a mesh of the people you want to work with to exchange more. So it's really to give you the knobs to decide what to do. And in this paper coming out, I
mm,
guess by supercomputing, we talk about the importance of the knobs because I, after 20 years of just making data available to anyone who wants it, it's not so simple anymore if they take the data, put it in their own AI model and return nothing, and you lose your sustainability.
mm,
So for the first time, I'm trying to ask the question, what are the knobs you give yourself in a node, in a commons, and what are the ways you work with a mesh? And I'm thinking, instead of just putting your data out there, you're going to have different consortiums, different
mm,
partnerships, and you build a custom mesh with your knobs. That's why we have the node and mesh cards, and you figure out how you do this.
mm.
Is that,
So we have two sorts of questions that come up in this
yeah,
sort of context
yeah,
from collaborators that I talk to.
yeah,
And one is really boring from a methodological point of view. They're like, look, the lawyers at our institution don't want us sharing data. Our models, our embeddings derive data, right? How do I think about these in this context? And like my honest answer has to be, well, these are a form of derived
That's
data
correct.
from the actual, right? And so if you're putting on your most conservative hat, actually sharing embeddings is still, sort of leaking out some of your data. So you still have to jump
Correct.
through a bunch of hoops to share this. And this AI mesh is not aiming to solve that part of the problem.
Well, I wouldn't say it's to manage. We don't see that as a problem. We see it as part of the environment. So
Mm,
when we say embedding centric, you might have missed this, but there's nothing to keep you from taking embedding algorithms that you use for inferencing that are quite generic. So they can be shared. When applied to your data, it's derived data. It is no different than sharing any other derived data. You
mhm.
decide who you're going to share that with. If you build a model, you decide who you're going to share the model. That's what I mean by the knobs. So
Yep.
for the first time, the role of the mesh, the role of the AI Commons is to allow you to do this and to think about it, to persist it in a model repository, to have an embedding service so you could decide what you share, data, embeddings, models, nothing. And then the role of the mesh is to expose those knobs in a shared way with the people you want to work with.
Yep.
Does
Yeah.
that make
It's
so?
much more, it's much more the sort of second problem that we come across, which is like in an infrastructure, right? In a management sort of sense,
Yeah.
how do we actually functionally work across these groups?
That's
And
the
that's
mesh.
really, yeah.
That's the mesh. But it didn't work in the old Gen 3 because the default was to share everything.
Mm,
So that's why in the age of AI, we have to just give you guys more knobs.
mm. And I
But you're
think Kyle
right.
made this point
Yeah,
a moment ago about, there's probably a lot of value. If you're thinking about federated learning, there's a lot of value in terms of thinking about the environment. I mean, that's a real problem in a lot of these
right.
federated packages that exist, right? They assume that you're all running in the same sort of place. That's not the case, of
That's
course. And
not the case.
yeah,
So and so, yeah, and this is why we took this embedding centric. I think it gives you a little more flexibility in how you deal with this. It also allows you to build much smaller models, which gives you less cost. It manages the cost. You're basically shifting the computation to the training of the embeddings, which allows smaller models to be built, but the training of the embeddings could be shared over multiple models.
yeah, and you can have a lot of flexibility with that. If you start thinking about fine tuning of these or adapting of these for specific
Right.
problems, I think it's quite nice.
Does this make sense? So we really want this to be a community effort. I think the problems are subtle and it's a little hard to understand them abstractly until you build these models and see what's there and what's practical. I think we're going to have to do that with these meshes and federation. I'm less interested in distributed models.
Mm.
That is, it's not that they're not interested, but I think if we will get more low-lying fruit from the community in first doing the federated models. I'm not against, they're not against distributed models if there's community support for it as something we want to do. I just see you get something quicker from federated models, but I'm open.
Mm.
I got a break in a minute. Ben, thank you for answering that question. Thank you for changing your name to your screen name to match your driver's license. Any other questions out there? Yeah, Bernie,
Oh yeah, can you hear me, Bob?
I can hear you.
Yeah, I put this in the chat, but I thought I would just ask anyway that this is just a general thing I've noticed is it'd be very useful to describe a series of user stories that explain the kinds of things that can be achieved with a AI Commons from the perspective of a non-technical expert. because I think we have a little bit of trouble sometimes explaining what this would actually be. And if we took an example like the cardiovascular one, and we could write down, well, with an AI Commons, you could do the following things. That having a few of those described would actually be really helpful for us to kind of sell the idea a bit more and get people on board with this. So I'd love to see that a bit more.
Yeah, and Bernie, and thanks for volunteering to help do that. We wrote this one paper together. I'm looking for the second one, so thank you, Bernie.
Yeah, no problem. Let's do that.
And anyone who wants to help. All right, I gotta say goodbye. This is the most fun I've had talking about AI Commons in quite a while. This is sort of the first public exposure of it. We'll be doing a general launch of this at Supercomputing this year in St. Louis in 2 weeks. So, we'll have more there. But I think Gen3 is in a pretty good place to work with the people on the call and your friends to sort of do something pretty interesting here. So thank you.
Thanks, Bob.
Bye-bye.
Thanks,
Bye.
everyone.